This is Notes 8.2. This one was talking about Pythagorean theorem, but before we jump in, we're going to practice one of these from the last lesson. Go ahead and try this and make sure you can find x, y, and z. Pause, and then I'll come back with the answer. All right, check it out. Make sure you've got those right. So today is all about Pythagorean theorem. It's about using the Pythagorean theorem to find the missing lengths of a side. Pythagorean theorem is just a squared plus b squared equals c squared. And then the converse of this, if something fits the a squared plus b squared equals c squared, then it's a right triangle. But first we have to make sure that you know how to identify C. C is the longest side of your triangle. If you make the right angle symbol into an arrow, it points right at that hypotenuse. So this is the hypotenuse. So we're going to use Pythagorean theorem to find these. So first find your A, B, and C. A, B, and then C has to be the hypotenuse. 6 squared plus x squared equals 12 squared. Go ahead and simplify this. 36 plus x squared equals 144. Take away 36 from both sides and you end up with x squared equal 108. But then you have to find the square root of this. So the square root of this side means that we'll get just x. The square root of this side means that we're going to get the square root of 108. But then we're going to simplify this. The square root of 108 is the same thing as the square root of 4 times 27. So x equals 2 square roots of 27 is the length of that side. But is that one simplified? No. I probably should have taken out a different factor out of that one. So this is going to be x equals 2 times the square root of 9 times 3. And so then square root of 9 is 3. 3 stays in the house. So this is 2 times 3 square roots of 3, which equals 6 square roots of 3. So I did that one by just taking out a partial factor of this. But you always need to go and double check to make sure that there's not any more perfect square factors in there. And if there is, it's okay. Just go and take it out again. And then multiply it times whatever you already pulled out in front. Okay, I would like you to see if you can figure out the dimensions on this one. Pause the video. Try to find x and y. So if you look at this, we don't have enough to do the geometric mean problems. We don't have enough to do Pythagorean theorem, but we can figure out this length right here by using Pythagorean theorem. So we do 6 squared plus whatever that is. We'll call it a. A squared equals 10 squared. And then if we work through the Pythagorean theorem, you end up with a equals 8. So now that we know that's 8, now we have just a little bit more information where we can actually use the geometric mean with this altitude. So I'm going to use the altitude equals the square root of 8 times x. Oops, I did the segment times the segment. So let me put the formula in here. Segment 1 times segment 2. So 8 equals the square root of 8x. Sorry, this is the altitude, so that should be 6. Square both sides, you get 36 equals 8x. So x equals 36 over 8, which reduces to 9/2. So then from here, you have an option which way to go. We could use the geometric mean to find this leg of the big triangle because 6 is an altitude. Or we can use Pythagorean theorem on this one. So I'm going to do this one with Pythagorean theorem. I'm going to change this to 4.5 just to make it a little bit more straightforward for you guys. So 6 squared is a leg. I'm using this on the triangle on the right. 6 squared plus 4.5 squared equals y squared. Multiply those together. And you end up with 56.25 equals y squared. So y equals the square root of 56.25. So y equals 7.5. So you might have to use a combination of your geometric mean and Pythagorean theorem to find some of these answers. Then we'll get to a little bit more applications. Perimeter of a rectangle is 44 feet. So think about this. The perimeter is 2L plus 2W. So right now I know 44 equals 2 times L. I'm going to call the 13 the L. So if I solve that, multiply and solve that, I end up with 9 for my width. But we want to find the length of the diagonal. Since this is a rectangle, we know this is a right angle. This is going to be the hypotenuse. So we'll call this C. And you just use Pythagorean theorem again. 9 squared plus 13 squared is going to equal C squared. Combine everything together and we get 250 equals C squared. So C equals the square root of 250. But we want to simplify that. So this is the square root of 25 times 10. 5 is the square root of 25. The square root of 10 stays in the house. So C equals 5 square roots of 10. That's the exact solution to this. So this is exact. As soon as you put it into your calculator, then it becomes approximate. Remember on the last lesson, I used the little squiggly marks when I round it. That's approximate. So when we ask you for the exact solution, we want the simplified form of the square root, no rounding. Okay, a square has diagonals 16 inches. Find the perimeter. Well, the perimeter, if we want to know that, we need to know the sides. So let's think about what we know about a square. If I know this is 16 and this is x, then it has to be x. All of these have to be x. So the area of this is going to be x squared. Well, I don't know what x is, right? So I do see that this is a right angle. This is the hypotenuse. So once again, x squared plus x squared, the leg squared plus the leg squared equals the hypotenuse squared. So this is 16 squared. Combine like terms over here. Divide by 2. So that's 128, I think it is. Yeah, 128. And then take the square root. So x equals 8 square roots of 2 when we simplify that and make it exact. So now that this is exact, I can find the perimeter. The perimeter is the sum of all of the sides, or 4 times the side length. The side length is 8 square roots of 2. So this equals 32 square roots of 2. That would be exact, and we need to add our units in there, inches. So exact is where we're at. Just be careful and make sure you lay it out and pay attention. The first time I went through and did the notes, I forgot to do the perimeter. So make sure you go back and read your question and make sure you catch everything. All right, you go ahead and try this one. So you should pause the video if you haven't already and try it. So x squared plus 16 squared equals 20 squared. You need to be able to identify where that hypotenuse is. It's the longest one. It's also what the right angle points to. So you should have gotten x equals 12, which brings us to Pythagorean triples. Because I look at this and I go, oh, this is 4 times 4. This is 5 times 4. So this has to be 3 times 4. So let's look at that. You can work it out with Pythagorean theorem, but the triples help. Turns out that if I have a C value of 5 and a leg of 4, then the other leg has to be 3. If I take this and multiply each of those 3 times 4 times 5 times 2, I get this. So if this is A, this is B, and this is C, if I know the side lengths are 3, 4, and 5, I can multiply all of those by any number and it's still a Pythagorean triple. So all of these turn out the A, B, and C like this. A is always the leg, B is always a leg, C is always the hypotenuse, the longest side. So it's kind of a cool little thing if you can memorize these. And if you notice that the hypotenuse is, say, 26, and one of the legs is 24, then you know for sure the other side is 10. So let's try this. Here I have a triangle with lengths of 24, a leg of 24, and a leg of 26. This looks suspiciously like 2 times 13. This is 2 times 12. So if I check my Pythagorean triple list, if I have a leg of 5, a leg of 12, and a hypotenuse of 13, it's a right triangle. Well, look what I've got here. I've got 12 times 2, 13 times 2. So this missing one must be 5 times 2, which equals 10. Okay, let's try this one. This is 17 times 3. This is 8 times 3. So this one, there's a triple, 8, 15, 17. So I've found an 8 times 3, a 17 times 3, so this has to be 15 times 3, which equals 45. The last part of this is checking whether something is an acute triangle, obtuse angle, or a right triangle. If something fits, we talked about this before, if a squared plus b squared equals c squared, then it's a right triangle. Well, it turns out that if c squared is less than a squared plus b squared and c squared is greater than a squared plus b squared, then I can figure out what kind of triangles these are. If c squared is greater or less than a squared plus b squared, then it's an acute triangle. If it's greater, it's obtuse. So the trick with this is to figure out your c squared and put it on the left, because that's where these equations are. If you switch it, then you have to switch the signs, but it's a little tricky. So first thing is you're going to determine whether the triangle can, the sides can even make a triangle. So the sum of two sides must be greater than the third. Okay, so that's what we're doing here. We're trying to determine if this is going to make a triangle. So first thing is to check that the two sides are greater than the third. We talked about this a couple chapters ago. Then you're going to classify the triangle by comparing the square of the longest side with the sum of the other two sides. So let's try this. First thing is check to see if it can make a triangle. So 10 plus 11, is that greater than 13? Yes, it is. Is 11 plus 13 greater than the third side? Yes, it is. Is 10 plus 13 greater than the third side? Yes, it is. Definitely makes a triangle. So now we're going to classify it as acute, right, or obtuse. So I'm going to start with c squared and see if it's greater, less than, or equal to a squared plus b squared. So c squared is always the biggest one. So 13 squared. Is that greater, less than, or equal to 10 squared plus 11 squared? Notice that I put c squared on the left, because if you do it, then it makes a little bit more sense. So c squared turns out to be 169, so this is acute. It's acute because c squared is less than 221. So there you go, Pythagorean theorem. That's what we're all about. Oh, if this one had been equal, it would have been Pythagorean theorem. Or it would have been a right triangle. Remember, if it's greater, c squared is greater, it's obtuse. C squared is less, then it's acute. If c squared is equal, it's right. And that's the end.